all. This is Muthuminal from the Department of Agricultural Engineering. Um, Today we'll see the continuation of remote sensing concept. The topic is physics of remote sensing. This comes under the subject GIS and remote sensing under the unit name remote sensing. Before going into the session, I'd like to have a small recap of the last class. We have seen something about remote sensing. I hope everyone will remember what is remote sensing and what is the concept involved in remote sensing and what is the history that is involved in remote sensing. These are something which we have seen at the previous video, and today we will see something about IRS system. So IRS is nothing but the Indian Remote Sensing Satellite System, which was initially launched in the year of 1988. It is a very bigger satellite operation system because it comprises of 11 satellites in operation, and it is the largest civilian remote sensing satellite constellation in the world, as it provides a major imageries in a variety of spatial resolutions, spectral bands and SWATs. Usually the data which we get from the geotechnical experts are from IRS system. That is, it has a several applications under the field of agriculture, water resources, urban development, mineral prospecting, environment, and disaster management. As an agriculturist, we always do depend on the data that has been collected from the IRS system satellites. That is why I have specifically quoted IRS system. Now I will show you several satellite series that are available now. So the first satellite series that has been launched was IRS-1A. It was launched in the date 17th March of 1988. It is the first operational remote sensing satellite for the purpose of large scale mapping. So this IRS-1A has a specification of LIS-1 with a resolution of 72.5 meter and LIS-2A and LIS-2B with a resolution of 36.25 meter. So with this resolution, it is capable of capturing very good images as a large scale. The next satellite series is FROST 2, which is a failure model, and it has been launched in the same year but in the month of July on 13th. Next series which has been sent at the space is IRS-1B in the year of 1991 in the month of August of 29th dated. It has a resolution of 72.5 meter, and it also comprises of the same resolution as such of IRS-1A, because it is mandatory for us to update the IRS-1A satellite which has been launched in the 3 years back due to the unavailability of payloads. The next satellite series which has been launched was in the year of 1993, which is IRS-1E, but it is a failure model. So this is the next satellite series that is nowadays available, that is IRS-P2, which has been launched in the year of 1994, and the resolution of this satellite is similar to that of IRS-1A and 1B, because after the 3 years it is mandatory for us to relaunch the IRS series. The next satellite which we have been launched is IRS-1C, which has been launched in the year of 1995 at the month of December, dated 28th. The resolution of this is lesser than 6 meters, and it has a LIS-3 resolution of 23.6 meter with along with a wide field sensor of resolution 189 meter. The PAN data is used for the finer spatial resolution used to sharpen and increase the resolution of coarser resolution imagery. That means that this satellite could be used for various geological, biological, and engineering surveys along with the mapping characteristics. The LIS-3 had also improved spatial resolution, which is only suitable for land and vegetation observation. The Wi-Fi FS data used for the very large scale mapping, mainly used for ocean monitoring, and it is predominantly used in this sector. The next satellite series is IRS-P3, which has been launched in the year of 1996, and it is specifically has a specification of Earth's natural resources, study of X-ray astronomy, periodic calibration of tracking radar located at the tracking stations. It has a component WIFIS, modular optoelectronic scanner, along with the Indian X-ray astronomy experiment with a C-band transponder. This makes it capable for tracking stations. The next satellite, which has been launched in the year of 1997 during September month, was IRS-1D as a continuation of IRS-1C. It has a band resolution of 6 meters along with a resolution of 23.6 meter along with WIFIS. So before going into the next slide, I like to have a small discussion on the previous class. What is remote sensing? Yes, that's right. Remote sensing is nothing but collection of data without any physical contact to any surface materials. So the data could be collected in a wider range and no manual presence is required while collecting the data with the help of remote sensing. The next IRS-P4, that is, it is also known as OceanSat, was launched in the year of 1999. It was used to study the surface winds and ocean surface strata. It is also used for the observation of chlorophyll concentration, monitoring of phytoplankton blooms, study of atmospheric aerosols and suspended sediments in the water. It specifically consists of ocean color monitor, and also it comprises of multi-frequency scanning microwave radiometer. This was launched in the year of 1999 in the month of May on 26th. The next satellite is TESS, which is also launched in the same year and same date, but it specifically comprises of PAN mode, that is experimental satellite to demonstrate and validate the technologies like altitude and orbital control system. So this is the continuation of the satellite series, that is IRS-P6 Resource Sat 1, which was launched in the year of 2003. In the year of 2003, we have been using this IRS-P6 Resource Sat specifically for monitoring the vegetation dynamics, crop yield estimates, disaster management support. So this plays a major role in the field of environmental science. So this satellite comprises of resolution 5.8 meter with LIS 3 resolution 23.5 meter in an advanced YFFS system A and YFFS system B. The next satellite series comprises of Cartosat 1, 2, 2A. These satellites have been launched in the year of 2005, 2007 and 2008. This first IRS satellite system is capable of providing in-orbit stereo images, that is the cartographic applications at the cadastral level, urban and rural infrastructural development and management in the land information system and geographical information system. It also provides the stereo pairs required for generating DEM and ortho image products. The component comprises of PAN4 PAN AFT with the resolution of 2.5 meters and 1 meter, which is same as that of the Cartosat 1 and 2 in the Cartosat 2A. The next series is RISAT 2, OceanSat 2 and Cartosat 2B. These were launched in the year of 2009 in the consecutive months of April, September and July. During the last week of this month. The RISAT is specifically used for weather remote sensing application where the disaster management applications could be taken care of. And the OceanSat is envisaged to provide continuity of operational service of OceanSat 1 with enhanced application potential. The Cartosat is a continuation of previous Cartosat missions which has a PAN mode with a resolution of 1 meter. Other than that of the IRS system, we also do have the INSAT system, that is the Indian National Satellite System, which are placed for the geostationary orbits, which provides the largest domestic communication satellite system with Asia Pacific region. It comprises of 24 satellites, out of which 10 are in service, like INSAT 2E, INSAT 3A, INSAT 4B, INSAT 3Z, 3E Kalpana 1, INSAT 4A, INSAT 4CR, GSAT and GSAT 12. The next system is Gagan system, and the Gagan system is nothing but used for two core constellations, that is GPS and GLONASS. The GPS is the United States based system, and GLONASS is among the Russian Federation system. The position accuracies where achievable with these core constellations are not good enough for precision approach, and this has been used under the land requirements of civil aviation. So the major milestone in Gagan is to conduct the PSAT, that is preliminary system acceptance testing, which was successful in the year of 2010. The next system is SLV, and SLV is the abbreviated as Satellite Launching Vehicle, which is usually was a four-stage solid fuel line launcher. It was intended to reach the height of 500 km along with a carry of a payload of 40 kg. The first launch was took place in the year of 1983. The next system is ASLV, that is Augmented Satellite Launch Vehicle. This is an update of Satellite Launch Vehicle, and it has a capacity of 150 kg satellite into the LEO stored. It is comprises of 5-stage solid propellant rocket along with this placing. It was started by the year of early 1980s to develop technologies needed for a payload to be placed in a geostationary orbit. The next is PSLV, the Polar Satellite Launch Vehicle. This was developed to allow India to launch its IRS system into sun synchronous orbit, and the small satellites into the geotransfer orbit. The reliability and versatility of the PSLV is proven by the fact that it has launched 30 spacecrafts. On the July 15, 2011, its 18th consecutive successful mission orbiting satellites was launched, and it has also provided the rocket with a 94 success rate. GSLV, it was developed to enable India to launch its INSAT type satellites into geostationary orbits. India's current generation of INSAT satellites weigh around 2 to 3 metric tons, and it is also capable of placing 10-ton payloads into low Earth orbits, that is LEO orbits. The next is ground segment. The ISRO telemetry tracking and command network provide mission support to low Earth orbit satellites as well as launch vehicle missions. It has a network of ground stations at Bangalore, Lucknow, Sriharikota, Port Blair, Russia, Brunei, Bike, Indonesia. The activities are organized into network operations, network augmentation for the applications in health monitoring, communications, computers, and control center facilities development projects. So, this has been set up an Indian Deep Space Tracking Network station at Bangalore for India's mission to Moon Chandrayaan 1. In addition to ISTRAC, the master control facility has also been located in Karnataka, Bhopal, Madhya Pradesh, and this monitors and controls the geostationary satellites for the operations related to initial orbit rising for satellites in orbit payload testing and in orbit operations throughout the life of the satellites. This interacts with the effective utilization of the satellite payloads and to minimize service disturbances during special operations. This is the reference video which I have picked from the geospatialworld.net.
I'm Rishikesh Samant. I teach geology in the Department of Geology at St. Xavier's College in Mumbai. Today I'm going to very briefly tell you the origin and the meaning of the term remote sensing, something which is very fashionably used today, very effectively used today. So let's understand the term remote sensing. Remote, that means something which is not exactly in contact or in physical contact, something which is far away. The far away could be something which is slightly away or even very far away. And sensing, the second word, sensing means getting information, getting data, getting any input. The input could be something like temperature, pressure, a photograph. When you look at these two terms, remote sensing, normally people just think of one technology, and that is the satellite remote sensing. Well, sensu stricto remote sensing is used primarily for the technology where we have sensors on board satellites orbiting around the Earth, which have scanners and cameras on them, which are scanning the Earth's surface and relaying the images down. And since it's collecting information about the Earth's surface from far away, this term aptly applies to this phenomena. But if you look at it in the broader sense of the word, even things like your sonograph, your medical imaging, even simple x-rays, they are all remote sensing, because you're getting information or you're getting data about things without actually being in physical contact with it. So if you want it as a precise definition, well, it's a process of measurement or acquisition of information of some property, of some object or phenomena by a recording device that is not in physical or intimate contact with the object under study. So that becomes the textbook definition of remote sensing. Do note, in the definition, there was no mention of satellites. So, who coined this term first? Well, for that one needs to go back almost 70 years. In the 1950s, that Miss Evelyn Pruitt from the US Office of Naval Research gave the definition. She used it to describe the science and art of identifying, observing, and measuring an object without coming into direct contact with it. So that is the same definition has been further expanded. I hope this definition is going to be remembered by you. So in the next video, we should go deeper into this technology. Thank you.
So that's it for today's session. I'd like to end the note that remote sensing was coined by Miss Evelyn from US, and she is the most responsible person where the remote sensing term has been coined. And today we have seen something about satellite series. See you at the next class. Thank you.